Okay, our next lesson begins on page 44 in your textbook. And this one is called higher derivatives. And now what that refers to is the fact that, well, up to now, you've been just taking the first derivative of a function. You found the derivative and you've stopped. That's what you get for the first derivative. But there's nothing stopping you from taking the derivative of the derivative. And if you do that, you end up with what's called the second derivative. And you can repeat this process over and over again to get the third derivative and the fourth derivative. And all of those derivatives, the second, third, fourth, and so on, they're all known as the higher derivatives. So that's what we're going to learn how to do today. It's not that difficult. It's actually a fairly straightforward procedure for the most part. Here's the notation that you'll see. Now, all of the symbols over here in the left-hand column, you've seen all of those before. That's the symbols that's used for the first derivative. For example, y prime, dy by dx, the derivative of y with respect to x, and f prime of x. You've seen all those before. Well, look at the symbols for the second derivative. Look how they're changing. You have y double prime. You have d2y or dx2, for example. F double prime of x. Here's the symbol for the second derivative of y with respect to x, and so on. Third derivative, look at this, that's called y triple prime. F triple prime of x. Here's the other symbols as well. And now if you go above the third derivative, you won't see like four little prime symbols. Like it's not y dash 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 dash. Instead, you see a y, and in brackets there's the number 4. And that doesn't mean y to the power of 4. It means the fourth derivative of y. Here's the other symbols as well. Right there. But now the more common ones would be this last one there and the first one. They're the more common ones, but you can see the ones in the middle as well. So the example right under that says find the higher derivatives for y equals 5x to the power of 3 minus 2x. Well, so we're going to get the higher derivatives there. And notice they don't tell us where to stop. They don't just say find the second derivative or find the third derivative. It just says find the higher derivatives. So what we do is we start taking the derivatives, yes, and we don't stop until the derivative doesn't change. If you take a further derivative, you basically end up with what you started with. And you'll see what I mean by that now in just a minute as we do these. So let's go ahead and find the first derivative, shall we? We'll call that y prime is equal to, all right, let me see what we've got. It's a simple polynomial. 5 multiplies by 3. Well, let me say, I think that's a 15. Then you have your x. There's your x. And you subtract 1 from the 3 to get a power of 2. And then there's a minus there. And the derivative of 2x, well, that's just a linear term, a linear function. So the derivative of that would just be 2 by itself. There's your first derivative. Okay, so we keep going. The second derivative, y double prime, is equal to 15 gets multiplied by 3 this time, so that's 30 at x. And what happens to the minus 2? It vanishes. The derivative of a constant is 0. So there's your second derivative. And now the third derivative, you can go further. 1, 2, 3. Okay, make it as 3 dashes is equal to the derivative of 30x is just 30. And we can keep going. We don't need to stop there because the fourth derivative will be different from the third derivative. So let me just come out here now. And so we have y, not 4 strokes, 4 inside a set of brackets is equal to, well, 30 now is just a constant. The derivative of a constant is 0. Now, do I need to do it again? No, because the fifth derivative would also be 0, and the sixth derivative would be 0, and so on. So you can stop there. That's all the higher derivatives for that one. So that example is completed. All right, let's look at the one that comes after that. And this time it looks like it's a fairly complicated function, everyone. We have f of x, well, at least it's explicit. It's not implicitly defined. So you have f of x is equal to x multiplied by, and then in brackets, x squared minus 1 to the power of 2. This is actually what we did a couple of lessons back. This is a mixed derivative. And they're giving you a hint here. It says to simplify f prime of x, simplify the first derivative. All right, so let's do that. We'll play their game. Now, by the way, probably the easiest thing to do here would have been to multiply it out to begin with. I mean, forget that x for just a moment. Square the binomial, which is pretty simple to do. Then multiply the result by x, and then you don't have to worry about using your product rule or your chain rule or your mixed derivatives. Then you can just go ahead and take the derivative anyway. Well, that's not what they ask us to do, so I'll tell you what. Let's play their game. F prime of x, the first derivative, is equal to, now, what is my pen going to last? Okay. All right, so let me see. We're going to have to use the product rule. The x is your first piece, and everything in the bracket squared is your second piece. So the derivative of the first piece, the x is just 1. We multiply that by the second piece. We don't change anything. So it's x squared minus 1 squared. Okay, so that's the first piece of our product, the first part. And then I go plus. And now the second part says I take the derivative, not the derivative of x, I just leave the x by itself. But I take the derivative of the second part, the x squared minus 1 squared. And that's where the chain rule comes in. So that's going to get multiplied by 2 in front of x squared minus 1 to the power of 1, right? 1 comes out of 2, but you don't need to write the 1 there. And then you have to multiply that by the derivative of what's inside the bracket, so x squared minus 1. The derivative of that is just 2x. There you go. There's your first derivative. Now they're telling us to simplify it. Okay, well, let's go ahead and simplify it. It would have been easier just to simplify it at the very beginning. I'm not sure why they're telling you to simplify the first derivative when you should have just simplified it at the beginning. Now remember, I'm not taking the second derivative yet. This is still the first derivative. I'm just simplifying it. Now, if you square x squared minus 1, you're going to get x to the 4 minus 2x squared, and then negative 1 times negative 1 is plus 1. That's what that's going to turn into. And this second part, well, I'll tell you what. If you multiplied the x by the 2 by the 2x, that's going to be 4x squared. So you multiply inside the brackets by 4x squared, and you're going to get 4x to the 4 minus 4x squared. Now, let's group together your like terms. Now remember, this is still the first derivative, and I'm running out of room. Yay. So what will this become? Well, let me see. I've got x to the 4 plus 4x to the 4. Well, I'm pretty sure that's 5x to the power of 4. And then I have minus 2x squared minus 4x squared. I'm thinking minus 6x squared. Gee, that 2 actually looks like a 2. And then I got plus 1 as well. So all we need to do now is, that looks much simpler. It's going to be much easier taking the derivative of that. But like I said, ladies and gentlemen, I personally, when I took the very first function, the original function, I would have simplified that. And you wouldn't have had any of that mess right there to worry about. Anyway, so if we keep going, we'll keep on going. How's that? So here's the second derivative. That looks like the 11 is equal to 5 times 4, 20x to the 3, and then minus 2 times x is 12x. And the 1 vanishes because it's a constant. So we can keep going now. We have triple prime of x is equal to 20 times 3. It used to be 60, I think it still is. Minus 12. And why stop a good thing when you go? Oops. There's why you want to stop a good thing. And your pen goes crazy on you. Okay, let's try again. 4 now inside the brackets. The fourth derivative of x is equal to 120x. And now the minus 12 itself vanishes. Now even that's gone. Let me come up here. Let me come up here. Oh my goodness. All right, pretend I'm coming up there. The fifth derivative of x would be just 120. And should I go once more? I think so. I can actually take the sixth derivative. And now the sixth derivative of x, because 120 is just a constant, now I get a 0. And now I can stop, because now anything after this is just going to be 0 anyway. So there's my sixth derivative. Okay, what do we have left? Okay, I'm not sure if you're copying that down or not, but I'm going to start erasing a little bit of that so I can clear some room up for myself. There you go. All right, so let's look at the example on the next page. Actually, I think there's 2 more. I won't get time to do both of them, but I might have time to do this one on top of the next page, page 45. So I'm going to try that one anyway. I'll show you. I'll start it anyway. Look up the last one on the bottom of page 45, or halfway down page 45. Look up the detailed solution on D2L for that one. And if you have any trouble, let me know, and I'll fix that one for you. I'll look at that one for you. All right, so here's this example. Y is equal to 2 divided by 1 minus x. You have to get the second derivative, and then once you find the second derivative, oh, look at this. You have to replace x with negative 2 in the second derivative, not the first, the second. And so yeah, that's done a lot in calculus, actually. Now, this function, I'm running out of time. This function right here, of course, do not use your quotient rule. Do not use your quotient rule, because the top is just a very simple 2. In fact, what you should do there is change this into y is equal to, the 2 stays where it is, and the 1 minus x, because it's in the denominator, you should raise that to the power of minus 1. Now, there's your function. Use that when you're taking the derivative. Again, let me repeat. Don't use the quotient rule there. Now, you'll get it right if you use the quotient rule, but you're making way too much work for yourself. All right, so negative 1 times 2 is negative 2 times 1 minus x. And then I subtract 1 from that negative 1, so now it's negative 2. And I then multiply that by what's inside, the derivative of the inside part. That's my chain rule. So 1 minus x. Well, what's in front of that minus x? Well, how about minus 1? There's the derivative of the inside part. So now if you wanted to, you could even simplify this a little bit by multiplying the negative 2 here and the negative 1 here together. So it's basically just 2 in front of 1 minus x to the negative 2. So that's your first derivative. Your second derivative, y double prime, would be equal to, okay, again, you have to use your chain rule. Negative 2 multiplied by 2 to give you negative 4. 1 minus x is inside your brackets again. Now you subtract another 1 from that negative 2, and you get negative 3. Okay, pretend that's a 3. But then you also have to multiply that once again by what's inside, the derivative of the inside part. So 1 minus x, the derivative of that is minus 1. So really, this now, you again can multiply the negative 4 times the negative 1. That's just 4. And you can even put this down in your denominator if you want. So here's what your second derivative really is, a 4. And then 1 minus x. You can put it in the denominator with a power of positive 3. And that's what you put your negative 2 in. Right there. Put your negative 2 in for your x. So 1 take away negative 2. Let me think. That's a 3, I believe. And 3 to the power of 3. Oops, I got it. Negative 2 is equal to 4 over 1 minus negative 2. So that's 3, remember. Cubed, pretend that's a 3. And voila, there you go. 4 over 27. That's what it is. Now that's not your slope though. You get your slope from your first derivative. But we'll see what again that is. Anyway, try the example on the bottom of page 45. And also now that you've got these 3 lessons done, these 3 topics, try pages 46 and 47, because they're all the rules, a mixture of practice problems for everything we've done in the last 3 videos. Okay, so I'll stop there. Any questions, give me a holler. Send me an email. Okay, bye-bye.